In this video, we're going to do a couple more examples from section 3.4. Not so much with the library functions. Well, we will be using some functions from the library, but we're going to talk about piecewise functions. Okay, so there's an extra example for piecewise and then a word problem. So the first one is that we want to graph this function. So g of x is 1 over x when x is in the interval from 1 to infinity. So that means x is strictly bigger than 1. Okay, if it equals 1, then we're 3. And if we're in the interval from negative infinity to 1, so that's x less than 1, it equals negative 2. So we want to graph this. So the first thing, the easiest part to do is when x equals 1. Okay, so here's when x is 1. And I know that the point is at 3. So 1, 2, 3. So I'm going to have a point here at 1, 3. Okay, so that's the point. That is from just that this middle part here. Okay, so that tells me that there should be a point there. Now, when x is less than 1, okay, for all times it's less than 1, but not equal to 1. Okay, but every other number that's less than 1, the y value is negative 2. So that means at, say, 0.5, it's negative 2. At 0, it's negative 2. At negative 3, it's negative 2, etc. So what's going to happen on this side is this is a constant function. So I'm going to have a hole at 1, because at 1 it's 3. But then it's a horizontal line up until then. So this side here is this horizontal line. Okay, so that's when, so this side here is a constant function. Constant at y equals negative 2. Okay, now at this point, at 1, we have a dot. Okay, and then when we're bigger than 1, we have the reciprocal function. Okay, so we want to graph 1 over x when x is bigger than 1. So let's think about when x is 1, it's going to be at 1 over 1. Okay, so maybe let's just write this. So at x equals 1, 1 over x is equal to 1 over 1, which is 1. So that means that we're going to have a hole. So there's no point there because the function it's not in the domain at 1. Okay, so we're going to have a hole at the point 1, 1. Okay, so I have a hole here. And then if you sort of know the shape, okay, the reciprocal function looks like this. So we just want the portion bigger than 1. So we're going to have something that looks like that. So it approaches 1, or approaches 0, sorry. We're going to have a horizontal asymptote at y equals 0. Okay, but that's what our function is going to look like. Okay, now what is the domain of this function? So think about, are there any x values that don't have a y value? So as I go along the x, so up until 1, the y values are always negative 2. At 1, it's 3. Okay, and then when I'm bigger than 1, it follows this line, so there's a point everywhere. So that means that the domain is all real numbers, or in interval notation, negative infinity to infinity. Okay, now what is the range? So you want to think, what y values can I get? Okay, so obviously negative 2 we get lots of times. 3 we get once. So I'm going to write those just in curly brackets because they're individual numbers, not intervals. So negative 2 and 3 occur sort of by themselves. And then we have this part of the curve. Okay, now that's going to hit every y value between 0 and 1. Okay, but not either of those values. So then we're going to have the interval from 0 to 1, but not including either endpoint. Intercepts. So let's do the y-intercept. Okay, so that's where it crosses the y-axis. So that's going to be this point here. So that's the point 0, negative 2. So the y-intercept is 0, negative 2. What about the x-intercept? So that's where we cross the x-axis. Okay, it doesn't actually look like it does cross the x-axis. so there's no x-intercept. Okay, so that's our piecewise function and a few details about it. Okay, let's try the next one. So, a sign at a parking garage reads as follows. So, they charge $3 for the first hour, and then $2.50 for each additional hour. Okay, cars parked over 8 hours are going to get a flat fee of $40. Okay, so C of t, our notation, is the cost to park for t hours. So we want to write a definition for C of t. Okay, so obviously it depends how long you park for. And it matters how many hours you're there. So they go sort of in integer values. Okay, so if you're there for an hour and a half, that actually counts as 2 hours because you're going to have to pay the $3 for the first hour and also the $2.50 because you were there part of the next hour. Okay, so we're going to have to write this as a piecewise function, and there's actually going to be quite a number of pieces. So if you're there an hour or less, you're going to pay only the $3 fee. So this is if t is between 0 and 1. Obviously bigger than 0 because if you don't actually park there, you're not going to pay any fee. Okay, but up until 1 hour you pay $3. Okay, now if you're there more than 1 hour, but less than or equal to 2 hours, then you're going to pay the $3 and the $2.50 once. So that's going to be $5.50. Okay, with those added together. Now, if you're there more than 2 hours, but at most 3 hours, then you're going to pay the $3 plus 2 of the $2.50s because you're there 2 additional hours. So that's going to be 3 plus 5, so that's going to be $8. Maybe I should write these as dollars. Okay, now if you're there more than 3 hours, but less than 4 hours, then I need to add $2.50 to that, so that's going to give me $10.50. Okay, more than 4 hours, but less than 5 hours, add $2.50 to that, is going to give me $13. Okay, now more than 5 hours, but less than or equal to 6 hours, add $2.50 again, that's going to be $15.50. Okay, now if you're more than 6 hours, but less than or equal to 7 hours, add $2.50 again, that's going to give me $18. I need this to be a bit bigger. So if you're there more than 7 hours, but less than 8 hours, I'm going to add $2.50 again. So that's going to be $20.50. And then if you're there more than 8 hours, okay, so more than 8 hours, there's a flat fee instead. You just have to pay $40. Okay, so that's what our function would look like. That's how we would define it. And then they ask for C of 6. Okay, so C of 6, maybe I don't want to, well, whatever. Okay, C of 6 is going to fall into this category here, right? Because you're equal to 6. So if you were there exactly 6 hours, you're going to pay $15.50. Okay, so what that means is it costs $15.50 to park for exactly 6 hours. Okay, now to give you an idea of what this function looks like, okay, so it's like a step function. Okay, so I have my hours, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so that's my T, and then this is the cost axis. So what it's going to look like is if you're at, so if you park for only 1 hour, or 1 hour or less, you're at $3. So it's going to be at 3, and then it's going to be a horizontal line until you get to 1. Okay, so that's $3. Now if you park between 1 and 2 hours, now it's going to jump up to $5.50, and then it's going to be flat again. Okay, and it's going to keep doing that. Oops. It's going to keep doing that until you get to 8. So this is 2, 3, 4, 5, 6, 7, so I think that's up until 7 hours. So between 7 and 8 hours is going to be a normal jump. And then once you get to 8, so more than 8, it's a big jump. So it would be like way up here. And then it would be like that forever. Because once you park for more than 8 hours, oops. Okay, so that should be at 8 down here. So once you park for more than 8 hours, you have to pay the $40 fee. Okay, but each of these jumps is a $2.50. So this is $5.50. This is going to be $8, and then I'm going to be $10.50. Okay, etc. So that's what the graph looks like, just to give you an idea of what a function like this would look like. So it's a constant function on each interval. So you get a horizontal line on each interval.